In computer science, divide and conquer is an algorithm design paradigm based on multi-branch recursion. A divide and conquer algorithm works by recursively breaking down the problem into two or more sub-problems of the same or related type until these become simple enough to be solved directly. These solutions to the sub-problem are then combined to give a solution to the original problem. In divide and conquer algorithms, there are two separate phases. First is divide, second is conquer. Let's talk about dividing first. As the name says, we are creating smaller instances of our problem and we are trying to solve those. I have here an example of two-branch dividing, but you can divide to more branches. When dividing, you must have some stopping condition, otherwise you would divide until there is no memory and we don't want that. In general, you want to have some b which defines at what point we start to conquer. Mostly, it is when the size of problem is small enough to solve it efficiently by other algorithm. For example, in merge sort, we were dividing until the size of our problem was equal or smaller than one element. Then we conquer. The conquering part creates solution by combining solutions to subproblems. In sorting algorithm, this is the part where the magic happens. For example, in merge sort, we knew that solution to our subproblem are two sorted arrays. So we take these two solutions and merge them into one. Let me show you a different example. We can count nth Fibonacci number by divide and conquer. Nth Fibonacci number is defined as add up of n minus 1 and n minus 2 Fibonacci number. Here's a pseudocode solving this problem. In the divide phase, we recursively call Fibonacci for n minus 1 and n minus 2. We are dividing until n is smaller or equal to 1. When that happens, we just return n. The conquer part is pretty simple. We just add up results for our subproblems and return that as a result. This might be a bit confusing, so let me show you an example. Our initial n is 4, so we divide into a result of 3 and 2. These calls still haven't met our ending condition, so we divide once again and get this. Most of our calls have met the ending condition, but we still need to divide 2 into smaller instances. All of our calls have met our ending condition, so we start to conquer. In conquer phase, we just add up solutions to subproblem and return the result of this operation. So we add 1 and 0, so we return 1 as a result of this subproblem. And we continue with row above, where by adding the result of our subproblems, we get these numbers. When we conquer these two recursive calls, we get our result.